The chain rule lets us calculate even more interesting derivatives where we have all kinds of rules that apply. In this case, we have a product. You see you have a function f times a function g, where f is 1 plus 2x, and g is e to the minus 2x. So since they're a product, we need the product rule that says y prime is f prime g plus f g prime, where f is 1 plus 2x means that the derivative f prime is 2, and the derivative of g prime, is negative 2 e to the minus 2x. That's because of the chain rule. We had e to the minus 2x from the derivative e to the x times negative 2 by the derivative of the exponent. So now for y prime, we have f prime, which is 2, times g, regular old g, e to the minus 2x, plus f, original f, 1 plus 2x, times g prime, the negative 2e to the minus 2x. And we can clean that up, so y prime equals 2e to the minus 2x minus 2e to the minus 2x minus 4x e to the minus 2x. That's from distribution of this term here and there. Then one might want to clean this up. For example, we have a 2e to the 2x in all the cases. In fact, this 2e to the 2x and that 2e to the 2x are exactly opposite of each other in sign. So we get y prime, the first derivative, is negative 4x e to the minus 2x. Very good. Let's see what other kind of problems we can do. Now we have a function f of x equals x squared times the secant of 1 over x. Again, we have a product right here where f is x squared and g is the secant of 1 over x. And inside that product rule, there's a chain rule right here. You have to use the chain rule. So let's find f prime is 2x, and g prime is the derivative of the outside. Derivative of secant is secant, leave the inside alone, 1 over x, times tangent, the inside alone, 1 over x. So that's the derivative of the inside, and then the derivative of the outside is the derivative of 1 over x, negative 1 over x squared. Now that's multiplied by all this piece of the derivative of the outside. So when we apply the product rule, y, or I suppose f prime, equals f prime g plus f g prime, we find that f prime is simple 2x, g is the original function, secant of 1 over x, plus f, original f is x squared, times g prime, and g prime is the big one. I'll put the negative 1 over x squared first, times the secant of 1 over x, times the tangent of 1 over x. And then clean it up. So 2x times the secant of 1 over x plus x squared times negative x squared. If we put that thing together, we have a 1. So just secant of 1 over x times the tangent of 1 over x. So I would say that's the secant of 1 over x times 2x plus tangent of 1 over x for the derivative f prime. So these things only keep getting better. We have g of t is this big quotient to the negative third power. So if you look at it, we have one outside function here, this -3 exponent, and then there's an inside function here, the quotient. And then again, we have an inside function here, inside the sign. So that will need the chain rule also. So this is almost like a double chain rule problem. Now before we get too carried away, let's see if we can't simplify the function a little bit. You might remember that negative exponents mean that things belong in the denominator. So 1 over all this stuff to the third power is the same thing as 2 minus 2t over 1 plus the sign of 3t to the third. Positive third because we flipped the quotient. We use the negative part of the 3 to flip the quotient. So that helps me a little bit. Maybe it will help me simplify a little bit from there. You could write this as 2 minus 2t cubed over 1 plus sine of 3t cubed, and then you could use the quotient rule and you'd have chain rule for the top and the bottom derivatives, but I think I will just work off of this where we have a chain rule, a quotient rule, and then a little chain rule inside. So first, for g prime of t, we have the derivative of the outside. The outside part is this 3 exponent. So we bring the 3 down, derivative of the mom, leave the baby alone, 3 goes down a power to 2, and then we have 2 minus 2t over 1 plus the sine of 3t. All that stuff on the inside stays the same. Now we're going to differentiate that inside with the quotient rule. So let's do that over here. If you're still writing out what the low and the high are, you could do that down here, but I will not anymore. Low is 1 plus the sine of 3t, low. D high, the derivative of the top is -2, minus high, all alone, 2 minus 2t, d low. So in d low, I need to consider the derivative of this piece, which has an inside at 3t. So by the chain rule, the derivative of the low function, so derivative of sine is cosine of 3t, and then multiplied by 3 because of the chain rule, because of the derivative of the inside. That all over the bottom squared, 1 plus the sine of 3t squared. So now we can clean it up like here's a 3 and here's another 3. Those 3's are free agents. We could multiply them almost, though, but we have this minus. So let's try to simplify. We get 3 times 2 minus 2t over 1 plus the sine of 3t, all squared, times, and we can distribute this -2 to both terms there. So -2 minus 2 sine 3t. And to the right, we'll have to distribute the cosine and the 3. So this is 3 cosine times that, and 3 cosine times that. And we'll put it in a big negative. So 3 times 2 made 6 cosine of 3t minus 6t cosine of 3t. All divided by 1 plus the sine of 3t squared. Alright, so that's 3 times 2 minus 2t over 1 plus the sine of 3t squared times -2 minus 2 sine 3t minus 6 cosine 3t plus 6t cosine 3t plus, because this negative, it got distributed, all over 1 plus the sine of 3t squared. So that's not too lovely. You might think that from these terms we can pull out a 2 in the least, and in fact that's really all you could get. So if we take a 2 out, we get 6 times 2 minus 2t over 1 plus the sine of 3t squared times, let's put these in positive order and descending orders of t. So 6 divided by 2 was 3t cosine 3t, that's from this term, minus, we'll do the next cosine, 3 cosine of 3t, minus the sine of 3t minus 1, all over 1 plus the sine of 3t squared. So we can't clean up too much. Maybe you think about like opening up these denominator powers and combining them since they're the same thing. You could do that in theory. The book probably factored out this 2 cosines of 3t just from that one term, and the 3 to make some parentheses in the numerator, but really we're not making big leaps towards simplification anymore. So we can stop right there, call that g prime, the derivative of g, and pat ourselves on the back for a big chain rule problem. So there you go.